A little bit about NextRev and myself. NextRev is the largest reseller of PTC products on the West Coast. We're based in the Bay Area, Santa Clara to be exact. We have operations in both Northern and Southern California, and we regularly service the areas in northern part of the country, in Washington and Oregon, and some of the other neighboring states. We offer a lot of courses. We do these courses. Most of the classroom courses are handled in Santa Clara, but we can also do remote courses, custom courses around all of the PTC suite of products. A lot of the common courses are going to be things like intro, update courses from previous releases of Pro Engineer to Creo and Windchill, and all the various modules within those tools, things like sheet metal, surfacing, cabling, simulation, and again, here we got modules for Moldflow, NC, all those sorts of things. So if you're interested in any of our training, contact us at nextrev.com/training. There'll be some numbers there. You can call us, or you can sign up for a course there. We have a lot of in-house experience around training, mentoring, consulting with the PTC products. So we should be able to answer most of the questions you have. If you've got any questions for us, you can send those to tech@nextrev.com or sales@nextrev.com. Tech, T-E-C-H. A little bit about me. I'm a PTC certified trainer consultant. Been working for NextRev for almost 5 years now. I've been working with PTC products for almost 18 years, and I have a lot of experience in mostly aerospace industry, Lawrence Livermore Labs, worked for PTC for about a bit as a consultant, and pretty much support the entire suite of PTC products. Okay, so yeah, and I should be able to answer any of those questions for you if you have any. Here's some of the upcoming power hours, doing Moldflow Simulation today, and then next week we'll be covering working with neutral file formats in Creo 3, importing them and altering the geometry per your needs. So using flex modeling, direct modeling approach that's newish to Creo Parametric Universe. It basically allows you to edit geometry that would otherwise not be editable in a more direct fashion. Okay, so you can see some of the other power hours coming up, and you sign up for those if you want to attend those particular power hours. Okay, so here's our agenda today. We'll be covering the Creo mold technology, Moldflow technology, not to be confused with Autodesk's Moldflow. We're going to be doing a little bit of a comparison between what comes with Creo and Moldex 3D's portfolio, which is going to be a more extensive list of functionality. Because the Creo mold tool inside of Creo is just more of a checking of your mold fill and any issues you might have with that fill. There are other things like accounting for warpage and those sorts of things that Moldex 3D, which is the technology being used here, would be able to expand on. And so any questions around maybe functionality that doesn't exist in Creo Mold, well, it's going to be in this Moldex 3D, which integrates with Creo as well. We'll be talking about doing some simulations on fill pressure, air trap, melt front time, a lot of the parts of the mold that can go wrong, essentially, and how you might be able to correct those. We'll also learn to leverage the material database and adding, and editing existing materials within the database. It's pretty extensive, but you may need to have a need for adding your own stuff to it, at some point. And then the main thing is determining the best gate locations, diameters, and that sort of thing within the mold. Okay, so here's some slides on some of the things that can, things that can go wrong, or go wrong in the industry as far as responding to accurate quotes, and basically getting a timely mold created and accurate mold created. So this is some of the challenges we see in the marketplace, and we just want to basically shorten that cycle up and make it so that you have a better quality mold and in a shorter period of time. So what is the Creo mold analysis extension? Well, it's first of all, it comes only in Creo 3.0 as of build code, date code M10. So if you don't have Creo 3 M10 loaded, you won't see this. And it basically, again, provides us with the ability to do some Moldflow simulation of our part. And what you're seeing here at the bottom with the chart here is most of what we can do leads up to about half of this functionality. We can do checking of wall thickness, moldability, weld line and air traps, gate locations. What we can't do is some of the other stuff you're seeing there, which is enhanced cooling, warpage. We can do fiber orientation, but some of this other stuff is going to come in the MoldX 3D's additional functionality, which you can also purchase and integrates with Creo. So this is a tool that's going to be used for the end-user design engineer, maybe not necessarily an analyst. And some of the things he can test for is, is this mold going to fill? Are we going to be able to fill it based on the type of material we use, the fill time, the sort of constraints we put on it as far as material, fill time, the temperatures that we're filling it at. And then once it fills, if we are able to get a full, if we're not getting a short shot on our mold, are we getting weld lines or air traps in areas we don't want them to be, causing imperfections in the part or weaknesses in the part? And if so, we can change the material, gate locations, number of gates, and try to optimize a better part out of that. Creo Mold is fully integrated using the same UI as the rest of the modules within Creo, so it doesn't take relearning a new interface. And again, we're checking for short shots, weld lines, air traps, sink marks. Those are the common things to check. So again, this is going to benefit us because we're going to be able to lower our cost of creating the molds and maybe mistakenly creating a mold that's going to not be what we need. And so you're going to see a return there fairly quickly. It is pretty easy to use. One of the bullet points there says provides or is extremely easy to use, and it's one of the easiest modules that I have been able to pick up inside of Creo. So that is not just a selling point, it is a fact. It takes very little time to get up to speed on this. It is, and I'm going to get into a slide a little bit later where there is a light version that comes with, default comes with Creo inside the base package that you can play around with today, no matter if you own the full one or not. It comes with a little bit of a limitation on the types of results you can see, but it's more or less fully functional. So pull up a part, make sure it's a solid, and go over to the Applications tab. It should be sitting there if you have the Creo 3 M10 loaded up. So this is a typical process that you would use with the CMA tool. You're going to design your part up, perform some sort of simulation, and check the results. And then if you have issues, you're going to go back through, either modify the geometry or the process conditions that you've applied through the mold. You may need to add, you may need to, and this, one of the things that you're not doing is controlling the gates and runners and those sorts of things. That would be something that would come with MoldX 3D if you wanted to control that level of the mold, but really it's just gate locations, gate size, the temperature of the material, and then other than that, it's more or less you're making part changes, adding ribs and geometry where they need to be to get that mold filled, that part filled appropriately. Okay. Again, what I was saying earlier, you get a free version of the Mold Analysis Foundation. It's a light version. It's free to all Creo users. Here you're seeing, okay, that was the thing I couldn't remember. You got the melt front time only, which is the only result you're going to get out of that. But at least you can get the general feel of the tool. And actually, you're going to see the full sort of cycle of how you set up the model. You just won't get all of the results. Talk to our sales guys about maybe getting a trial version of the full version of Creo Mold if you're interested. Here is how Moldex has separated out their functionality. So you'll see eDesign Basic and eDesign. Those are more or less in Creo. The rest of this Professional, Advanced, and Solution add-ons, they basically are going to be stuff that you're going to need to buy as a separate package to the mold tool. So you get all the functionality within an eDesign Basic, which is just checking the fill. But if you want to have, again, you're looking at warpage, looking at designing the mold runners and sprues and those sorts of things, you're going to need to bump up to the Professional Advanced versions of that tool. Even though you're not going to have the modules not going to be sort of integrated and look like the rest of Creo, they do have a toolkit app, eDesign Sync, that locks into Creo and more or less works like the rest of the software. So if you guys have ever used a toolkit, a lot of the extensions and modules and Creo start off being those anyway, so you probably used one of those in the past. Here's just another slide showing the breakdown of the eDesign Sync PTC Creo stuff outside of the Creo Mold. You got the Creo Mold Analysis to the far left in the yellow, and that's the stuff that we can do now. And then you got everything else to the right in the gray is stuff that you would need to bump up to the professional versions for. Warpage prediction, flow balance, residual stress, shrinkage, all those things would need more potent set of software. And here we go. Here's some of the, just one more slide on some of the things you get with the, so the 2, 3, and the 4 are the professional versions: shrinkage, compensation, minimizing warpage. Those are ones that don't come with Creo Mold. Oh, and one last thing, if you're doing any overmolds, this is another thing that you would need to bump up to the professional versions on to get that functionality. So if you're trying to do like a true overmold with some various materials, then this is something that Creo Mold really can't do or give you reliable results on. So. The other thing that Creo Mold can do with additional licensing is it can you can cluster out your analysis processes if the parts are complicated and they're taking too long to get results on. You can run this through a bank of machines that are going to do the number crunching for you. So you can see the parallel computing here to speed up times of those additional processors. And this is just a comparison between what used to be in Creo called Plastic Advisor, that was Moldflow technology, compared to what's currently in the system on the left, which is Creo Mold Analysis. You see true 3D solver compared to a 2D analysis. It's like a 2.5D type of analysis done by Moldflow. So Moldex provides a better result, a more accurate result. Here we got just the benefits and features of it. Again, just a kind of a summary on the tools here. Ease of use, fully integrated, 3D solvers instead of a 2.5D solver. And it can be used by anyone. It doesn't have to be used by a specialist. Design engineer is the target audience here. Okay, so design a part, you do the analysis, and then you're off and running. Okay, let's do a live demonstration of just kind of walk you through the process of setting up the mold, the analysis, and show you kind of some of that stuff there. Let me just get this set up for us. Here's our part. It's a kind of an older phone part that we have here. I'd say an older, much older part, since we're mostly using smartphones these days. So let's take this part, and we will, the first thing I'm going to do is I'm going to bring in some existing analysis, because it does take time to run through the steps. I want you guys to see kind of the end result first. So I'm going to switch over to my analysis tab and click down on the mold analysis, which is going to give me the interface for mold analysis. Now, I have already loaded a project file, so that's important to note, because if you're, you know, if you're going to come back to some analysis you may have done previous to this part being open the last time, and you want to go back to the results that you created and build upon that, it's important to be able to save to a project, and that's kind of what I've done here. Is I've saved the project file, and now I'm going to go ahead and load it up. This takes a little bit of time, but much less time than it would to actually run the analysis again on it. So it's a way for me to get in there and show you guys some stuff really quickly. And you can see the gates here already. There's 3 gates showing. They just have a more graphical sort of indication of where those gates would be, and it would just kind of drop in some geometry there for that. Now, if I go to select analysis, and this is just going back into the analysis that I just read in, you can see that 2 runs have been recorded. Run 1 with 2 gates, run 2 with 3 gates, and I can even see the parameters that I placed on it, the material that I used, fill time, melt temperature, and mold temperature. Let's take this and look at 2 gates first. I'm going to go ahead and click on that and say OK, and that's going to then show me the results of my first analysis. And so I like to kind of show the, you know, the results first of what we've done here, and then I'll go back and kind of peel back the layers and show how it got to this point. So you'll see that it's showing us the melt flow pattern first. It's just showing us, you know, the areas of the model that get filled first, essentially, and then last. And we can actually animate this, which we'll do in a bit. Moldability is good, and that just means that, you know, this mold is, but you know, it's full, it's filled. There's no short shot. It completely filled the part up, or the mold up. We do have some air trap areas. Now we can walk through each one of the results. You can see there's quite a few here, or we can actually go to the results advisor, which is going to point out the areas of the model that, or the part that we should be more concerned with. And basically it's giving us issues that it found, so air trap issue, and it tells us what, gives us a description of the air trap and what that can cause, voids or surface defects. And then we also have a suggested solution here, and you can actually see, you know, kind of what happens there with the air traps. Increase the filling time, change the gate location, and a lot of this is, you know, try it one way, try it another way, see if it gives us a better result. Reduce the injection speed, and then modify the size or location of the vents. Now that's something, that's an interesting one, because that one is not something we can really do in the mold design package, but this is something you could do you know, with the higher level functionality. So here we go, we got another one, another found issue, degradation resulting in you know, a melt temperature that is more than the maximum temperature. We can change the gate location, increase the filling time, or reduce injection speed. We've got a slightly unbalanced flow, although I would say this is fairly good for both gates. You have near 50% balance there. I've seen it much worse. And then we have weld lines within our part. So this might be areas of weakness, areas that may actually, you know, break apart if we're not careful with where those weld lines end up. So I've done several analyses in here, and you're going to see weld lines regardless. It's just a matter of where you can bear to keep those weld lines, I would imagine. So that's something else you can look at. And you can see it just kind of guides you through those air traps, weld lines. We can take a look at those here as well. Now, if we want to take a look at, say, just kind of watch this animation, watch it fill, we can actually watch it through this view control here. It does start us off with a clipping plane, in which case we can, you know, drag through the part and view the plane in a 3D fashion. It's almost like a cross-section through the part. And because this is a 3D solver, you're going to see, you know, it's going to be of value to be able to do those cross-sections at this level. You can change the upper and lower limits of the legend, and then, of course, you can animate. Let's actually increase the speed here, and then we'll go ahead and run through an animation. And it just cycles through. Now, one of the other things we can do is we can pull up some graphs on sprue pressure, clamping force, and flow rate. So sprue pressure is expected to go up the more material we're adding. We can actually overlay the analysis results with our plots and watch those together. Okay, and then how do we record our results? Well, you know, again, what I was saying before was you could save your analysis and then share that with someone else that may have access to the mold analysis extension, or you can generate a report here, and you would fill in this information: title, author, company logo, and this is going to create a PowerPoint presentation with each one of the results that you see here included on each slide. You're going to have one of these results. Let's just take a look at some of these other results we have. Material orientation. Gate contribution. This is the, you know, the balancing of the gates that they're showing, so you may need to relocate the gate if one's contributing more than the other. Shrinkage that might happen as the part cools. You've got the velocity vectors, maximum cooling times. By the gates, you're going to have you know, maximum cooling time is going to take a bit longer, and you have maximum shear rates, temperature of the part. Again, we're going into now sink marks and weld lines, and the other stuff that we've already kind of covered here. So what I'd like to do now is run through the setup of this model. Let me just erase everything out of memory here that I have. We'll go start from scratch, essentially, is what I'm going to be doing. Okay, we're going to load up mold analysis, and we're going to basically what we're going to do first is we're going to set up the material, select the material. So let's just go grab, let's see, this material here. Now, what I was going to say before on the material setup is that, you know, you got your physical properties, mechanical properties, of course. You see plots on viscosity, and if you don't have the material that you need here, you can either customize a current one, copy it basically, and customize it to your needs, or you can add a material from another material database. And so it's pretty lengthy, the number of materials that are in here. And what they do is they kind of break it down by type, ABS, polypropylene, whatever it might be. And within those, you're going to have the various manufacturers, suppliers, and then their grade. We're going to pick this VA29 and apply that material. And then we're going to set up our gates. There's a couple of ways of setting up the gates. You can do an automatic gate creation, or you can do a manual gate setup. Let me do the first one. I'm going to do a manual gate setup so you can see that. We'll say add, and then we just need to click down on the surface of the model to add that gate. We can enter the diameter of the gate and then say OK. It records that position, and then I can actually edit the gate location if I need to, or delete it and recreate a new one. Let's go ahead and get rid of it, and let's let Creo do the work for us. I'm going to click on automatic gate creation. Let it calculate the best locations for this. Okay. All right, let's take a look at, actually we did one gate. I'm sorry about that. Let's do 2 gates. I'll calculate that again. There have been some instances where I will run 1 gate on the part with a specific fill time, and the part did not fill. So on this one, I think that was the case, and so I think it needs at least 2 gates with some of the fill times that we're seeing with the material, or suggested fill times, I should say. All right, there you go. And you can see in the hot areas here, the red areas, those are where the gates are going to be placed. Let's go ahead and apply those, and you can see one's sitting here and one's sitting here. Let's close that up, and you can see those more clearly. Now, is that a good place for a gate? Maybe, maybe not. Probably would just maybe relocate it to here. It's up to you guys, or maybe atop of this this rib. Okay, now the next step, and you can see that you basically work your way across. That's kind of how PTC is approaching a lot of their interface these days with these tabs, is that you kind of work your way across building out the analysis or model, geometry, or whatever it might be. Now that we have our gate locations, we're going to set up the analysis to run, and you'll probably get that on the first run. Okay, and let's see. We have our ABS, Asahi Stylic VA29. It's recommending a fill time, melt temperature, and mold temperature. Now, if you go back and look at material, there is a range for some of these things. You know, you can go to the top end of the range or lower end of the range, kind of play with the numbers a little bit. And if you try to go outside of the range of these numbers, it will kind of balk at that, and it'll let you do it, but it'll say that you're going outside the range of that for that material. Now, if I were to run the analysis on this now at a course without maximum cooling time and sync marks, it would be a fairly short analysis calculation time. But if I bump this up to be more accurate and add those two, you could be looking at 20 minutes, 30 minutes. It depends on the material, of course, and some of the other stuff behind it. But I'm not going to run this analysis because you've already seen the end result. And we'll go ahead and cancel there. Let me just go back to retrieving my project file. And I'm going to show 3 gates versus 2. Let's just see if using 3 gates versus 2 is going to help us with our weld lines, air traps, and sink marks. We do have the 3. I just want to make sure that it is going to use 3 gates here, so I'm going to select it and just say OK. Okay, we got our 3 gates now. Let's watch our, let's see, before I do that, let's take a look at the pressure we're applying to the sprues. And we'll check the melt front time first. Actually, before we do that, let's do a results advisor and let's see if it improved any of our problem areas of the model. Here we go. All right, so the sink marks are no longer in this list. Now, just because we have weld lines doesn't necessarily mean that we can, basically call it quits and try another analysis. It really depends on where those weld lines are and if you can kind of live with those locations for the weld lines, as well as the air traps. Let's just say that this model is good. I'll run some animation on it. So we can watch this spill. Yeah, looks good to me. Moldability is good. Air traps. Yeah, do I have any air traps on the other side? Yeah, a couple. Weld lines, quite a few still, but with all these little areas in here, I'm not really sure how much we can avoid that. Are we going to have any sink marks? There's a couple of areas for the sink marks. Those are obviously you're seeing where the gate locations are. So that might be, lowering of the temperature might help with that, but you have to play around with the numbers until you got the result you wanted, but sink marks are no good. You don't want those on the part, especially on the outside. Yeah, so that's pretty much it in a nutshell. That's, there's not much more to it than that. You're basically setting up your material, your gate locations, and then you run your analysis. You can store your analysis in project files and rerun your analysis by selecting the analysis, and then in the end you can view it through animations and reports and view all of your analysis. If you've got the mold design extension can be shared between multiple users, and if you've saved your project files to a maybe Windchill or to a folder, a server folder, you can then share that out to the team and they can view those files through the same application. Alrighty, well that's it, and I wanted to wrap it up there. If you guys have any questions, go ahead and hit me up with them now, and I'll try to answer them. If not, see you next week. Okay, I got two questions here, the good ones. One of the questions is what technology we're using. It is not Moldflow. Creo used to use Moldflow in, I believe, Wildfire, Creo 1 and back, or actually Creo 2 and back. They used Moldflow technology, but since Autodesk acquired that, they've now switched over to Moldex 3D. Look them up on the internet, Moldex 3D. They are legit. They have claimed that their technology is better, and everything I've read so far, kind of leads me to that same conclusion. Make your own choice there, but it's Moldex 3D, not Moldflow. The other question I have is everything that is seen here included in the free mold analysis? Yeah, all of the materials, the stuff you see here, the setup, you can do all of this. You can even save the project files. The thing that you miss out on not having the full version is all of this analysis, all of the results. The only result you get is the melt front time, which is the analysis, animation that I showed you before, and then the results advisor. You may get these guys over here, I'm sure you do, but you just don't get all of the other results that you see here. So if you're curious about it, if you're using Creo now, Creo 3, you should be able to see it inside of. And if you're using build code M10 and up, you should be able to use this right now. Make sure your model is a solid and not a broken up set of surfaces. It's got to be solid geometry. So hopefully that answered the question. Okay, guys. Well, have a good weekend. I'm not getting any other questions. Again, try this out if you're interested. If you got any questions for us, let us know. Or if you need more information about it through a demo, we can also arrange that as well. Have a good weekend, and join us again next week.